Hello, welcome to Taxonomy Online. Today we want to take the topic differentiation from the first principle. Alright, to find the differentiation, we are taking a curve. We want to find the gradient of a curve. Normally, differentiation is also the change on the y-axis over the change in the x-axis. So it's more or less the gradient function. So we want to find the gradient function of this curve. If I have a point A and a point B on the curve, if I draw a line, it becomes a chord. We know from here we are x1, x2, y1, y2. Then let the equation of or the function of the curve be y equals to f of x. So if y equals to f of x, then it means that y1 will also become f of x1, then y2 will also become f of x2. So it means this place we have that, and this will also be for this, as y is y1. Now we know that from here to here is a change between the x2 and x1. We use this to represent the change on the x-axis. So if I want, I can also know that if I'm looking for x2, x2 simply means that I am adding the distance from here to here. So it means x1 plus the change on the x-axis. So that can also be x1 plus change on what? The x-axis. That's the small change on the x-axis. Okay. So if I want to represent all this, you will see that the x2 is also here, which can also take this. So this can be extended in a way to have my function of x2, which is x1 plus the small change on the x-axis. So these are the values that we get from the function of the curve. Now, if I'm asked to find the gradient of the curve, we know the gradient is the change on the x-axis, on the y-axis compared to the change on the x-axis. So that simply means that if I'm looking for gradient, gradient is going to be the change on y-axis over change on the x-axis. So this change could be y2 minus y1 over the change, which is x2 minus what? x1. Alright. So this is what we use to find the gradient of this curve or of this chord. Now, if you want to substitute the value of the function back into what we have, we can see that from here we are seeing x2 minus x1, and from here I have x2, x1. If I subtract x1 from x2, I get what? The change. So it means the small change on x is nothing but x2 minus x1. So if I want to carry this information back into the gradient function, that is going to be, the gradient is going to be y2. y2 is the function of f of x2, which is the addition of this. So that is going to be function of x1 plus the change on the x-axis. Then you have what? y1 to be minus function of x1 all over x2 minus x1, which is also taken as what? The change on the x-axis. So if just substitution of this function back into the gradient function, we get something like this. Alright, now we know that this is just a change on the x-axis. So if I am drawing the point B closer to the point A, it will get to a point whereby the value of our x will become what? 0. So it means we have to set the limit for the small change in the x-axis. That is where we can apply the limit. So we can say that less the limit of this as the small change we have. is approaching what? 0. So this is what we normally call the differentiation by what? The first principle. So if I want to rewrite it, it's going to be, we know the gradient is the change on the y-axis over x-axis. So I have dy dx, which is going to be the limit of this function we have here, which is going to be the f x1 plus the small change minus the function of x1 all over the small change we have as our small change is approaching what? 0. So this is the equation or the formula that we can use to differentiate from the first principle. Alright, if we check some of the textbooks, you can see that if you have this with the curve, the difference from here to here is taken as h, as the small change on the x-axis. So if I have x2, the small change, some places this small change is indicated with what? H. It means where I have all the small changes, I can also substitute that to become another function of the limit of f, if I like f naught plus h minus the function of this all over h, while we have our h also approaching what? 0. So these are the two formulas we can use for differentiation by what? The first principle. So if you have y equals to 2x squared and you are asked to differentiate this with respect to x from the first principle, what we do is that from the formula we know that y is the same as f of x. So that means that our f of x is the same as what? 2x squared. If y equals to this, then our f of x, which is the same as y, will equals to 2x squared. Alright. We also have f of x plus h. You know the x in a bracket is here before the constant multiplier. So this will also give us 2 as a constant multiplying x plus h all square. That's square. Wherever I see x, I put in x plus h. So this become, the bracket become a polynomial, whereby we can hold our 2, then we expand this. When you have this with the square, we square the first, which will be x squared twice their product, meaning multiply the 2 times 2. So it's going to give us 2xh, then you square the last, which will be h squared. So that bracket has nothing to worry about. We only multiply by the coefficient, where that will be 2x squared plus 4xh plus 2h squared. So now your dy dx is just going to be the limit of this function minus this function all over h, where h approach what? 0. So what will I do? Wherever I see this, I slot in this value. Wherever I see this, I go back to original function. So this will just be, if I'm holding the limit, I want to hold it, substitute before. So if I substitute, I'll be having 2x squared, 4xh, 2x minus the function to be x squared. All these still remain to be under h. You can see clearly that this is 2x squared, 2x squared minus, so this will cancel this. If that is out, then we are left with only 4xh, 2h squared, I think that's all, divided by what? H. You can see h, we can factorize. So we factorize h out, we will be left with 4x plus 2h all over h. So this h will also take care of that h. So we are just left with something like 4x plus 2h. Don't forget, we are still holding the limit. So if I put all this into the limit while h is approaching 0, so whenever I see h, I put 0. So this becomes 4x plus 2h, and the h is what? 0. So all the way, the answer we are looking for, dy dx, is just going to be 4x. So if you are doing the differentiation from first principle, all you do is that you make sure you take each of the function, the f of x, you expand it, the f of x plus h, you expand that, then you perform all operations, and that will be all. Alright, thank you very much. This remains Taxonomy Online Mathematics. See you in the next episode.